Hello everyone, I'm going to introduce foaming in anaerobic digestion, and this is a very big problem actually in this digester. I'm going to introduce what is foaming and how to form it and what is the reason for that, and then what is the effect, of course, of this foaming and how to reduce the foaming. The first thing that we need to talk about is what is foaming. The foaming is a complex three-phase system consisting of bubbles of course, of biogas and liquid, which is mainly surface active substances or hydrophobic substances, and solid particles. Solid particles here means that some of the solid in the digesters and also microorganisms. And of course, here, this is what they call it complex three-phase system. The gas in this three-phase system representing about 90%. And the remaining, of course, is the solids and the liquids. So what happened here is that the bubbles of gas is going from the bottom to the top. And while actually going up, it's attached to this kind of solids. And while it's actually reaching the surface, it can burst, and then it can also go from the gas outlets or accumulate on the gas outlets or overflow under normal conditions. The other possibility is that this kind of surface active substances or hydrophobic substances in the liquid phase, and of course these bubbles can be captured and align at the liquid gas phase. So basically here interface, sorry, it can also interact here at the surface of the gas. Of course, we have the gas phase here. This is the head space of the digester, and here this is the liquid. What happened here, this is basically this three-phase system. The bubbles go up and then align by the gas liquid interface and forming this kind of buffer layer, lamellae with sufficient mechanical. This kind of buffer layer has higher strength or mechanical strength that can prevent the bubbles from bursting. Means that the bubbles actually just to form this kind of blanket here or this kind of layer here. So basically, this is what we see here. This is basically the bubbles over the surface of the reactor. What are the effect of foaming? This is the formation of an inverse solid profile with a higher solid concentration at the top. Because actually what happened here, while the bubbles actually go up, it's actually take some of the solids up. So basically you have this kind of inverse solid profile, means that you have higher solids at the bottom, maybe also in the lower part you may actually have lower solids, which means that the opposite of the normal operation, that the solids should be in the bottom of the reactor. Of course, this make a dead zone, means that the efficiency will be less in the bottom layers. And of course, this reduces the effective volume, basically, because most of the solids actually went up to the surface of the reactor. Of course, this kind of bubbles also can block the gas pipelines, causing a lot of problems, and maybe also need a lot of maintenance. And of course, this is a capacity loss because of the dead zones. Of course, this also, if you have this kind of bubbles and you have some kind of microorganisms around them, they may actually also cause microbial lysis, so means that less active biomass. And of course, the losses of microorganisms and the substances and the enzymes, because basically all of these solids accumulate there either they can actually stay there and maybe also can cause scum actually also. Maybe also not only foaming, but also this kind of scum, this very tough layer on the top that can be dispersed easily. And of course, all of this reduce the digester performance, and this be reflected on the amount of the biogas or the conversion rate of organic matter in the digesters. And of course, all of this needs some kind of cost to overcome it, either for maintenance or to defoam it. So basically, you need to take care of this problem to be able to have a reliable performance again. In a study, what is the potential causes of the foaming? A survey has been conducted in Denmark for 16 full-scale digester plant, and the result of this survey showed that 15 of the biogas has experienced foaming problems. So this basically serious, basically very, very significant number of digester has this problem. 6 of the plants observed that foaming occurred also in the pre-digester, basically during also the storage of substrate. If you have this kind of liquid type of substances or feedstock, you may actually also have this kind of foaming. And the result of this foaming, again, this is just to also confirm the problem that the problem of foaming, that the biogas reduced by 20 to 50%. This is very actually significant reduction. Okay, so again, this is just to have this kind of digester only about 37%. So basically mean about 37% of the 16 digesters has foaming, and the substrate storage about 20% of this, about maybe three digester or the digester system has this kind of foaming in the storage of the substrate, and 38% of the surveyed systems has both, means that they have foaming in the digester and also foaming in the storage of substrate. Only 60% of the digesters, which means what? This, only one digester has never been a problem, means that they don't have any foam. What was the reasons for that? Basically, the main reasons is high proteins and high ammonia in the feedstock. About 4 of this surveyed systems had either high proteins or high ammonia, and of course, this means that this kind of surface active substances, this kind of proteins, can cause this kind of foaming. Besides that, they have also organic overload. If you have organic overload, you can expect also that the foaming can happen. And or maybe also if you have feedstock with high fats, you may also have this kind of problem of foaming. And about 60% of these surveyed systems said that because of the unsuitable mixing systems. 19% of the surveyed things, they don't know actually what's the reason. So basically, you can actually also expect the foaming to be there, but no clear reason for the foaming. But finally, there should be some reason, either for high proteins or high organic loading, or maybe also fluctuating of the loading, fluctuating of temperature. Also, this another problem. Or maybe also some kind of bacteria there. They can also cause this kind of foaming. Besides these factors that has been surveyed in the Danish study. Okay. Okay, how to control the foaming in the digester? Based on the survey, the same actual study that I just mentioned, also they applied several things. They either add limes or increase or decreasing the steering. Also, maybe also basically you have consistent the steering. You can also have the reduced the foaming and decrease the temperature. Dilute the reactor content. Of course, if you have more solids, you may actually also have the chances that the solids can attach to the gas and float up to the surface of the digester. Increasing also increasing the flow rate. Also, maybe basically you control the flow rate. If you have this kind of high turnabout, you may also reduce the foaming. However, this may also be can be increasing flow rate means that you actually reduce the HRT, but still also this based on this study, only 9% said that if you decrease the HRT, you may actually be able to decrease the foaming. But still also, again, all of these measures, all of these techniques to reduce the foaming or to control the foaming is depending on the system and depending on the substrate. Of course, adding again oil maybe also helps, and use foam absorbers. This only maybe 1 or 2 digester used that, and of course decreasing the liquid volume or decrease the loading. Basically, decreasing the loading means that you have to dilute. Basically, dilute means that you have less solids there, and this will be reflected on reducing the foaming. Of course, besides this study, you can also avoid temperature fluctuation, which is basically one of the reasons, as I mentioned, for the foaming formation. And to avoid this, maybe you need actually to heat up the influent of the feed, basically to heat up the feed, or use bacteriophages, which is some kind of antivirus that also can attack the filamentous bacteria to reduce the foaming potential of activated sludge. This basically also can be one of the techniques to reduce the foaming. Of course, you use buffer agent, maybe sodium bicarbonate, sodium carbonate can also, or ammonium chloride, depending on also basically in the system stability. Besides that, you may also watch for a lot of, actually, you may find also some kind of defoaming agent in the market. You can also use them, but you have to also be aware of the fact that this defoaming agent should be free of silicon to prevent siloxane formation. With that, I end up here, and I welcome any comments. And thank you, and see you next time.